Hello and welcome, everyone. I am Ryan Moffett, Customer Service Technical Support Specialist here at Radian. And today we'll be talking about power quality testing using our RW-3X series. Brief overview of what we'll be discussing today is power quality in depth on the RW. I'm talking about vector diagrams, how to see those, primary and secondary readings at a site, waveforms that you can then see on your RW, trend data using the RW as a power quality monitor and viewing a trend over time of volts, amps, and other metrics. Saving data that you are looking at in the power quality menu, as well as saving harmonic content to then be used later, either in the RW or with one of our 4000 series decibels. So with that, let's bring up the RW. Start there. So when you first boot up the RW, this is what you will be greeted with. You'll be greeted with your WinBoard embedded main menu. Once you get into the RW, you can then go into power quality to do what you're wanting to do. Once in power quality, we'll go ahead and load this up here. You have a plethora of different options to choose from, and I'm going to walk through each one and how to navigate through power quality. As a precursor to talking about power quality, I want to talk about the setup I've got going here so you can kind of understand what you're seeing. I am generating behind me a 120 volt three-phase service, 1 amp on the secondary and 20 amps on a primary. So I have 20 amps going through the primary of 3 CTs behind me, which is then feeding the 100 to 5 CTs and then generating 1 amp into the secondary of all 3 phases. So for this demonstration here, I'm generating a perfect sine wave, 3-phase, 20 amps into a primary to 105 CTs feeding that with 120 volts across all 3 phases. So with that being said, that'll give you a little bit more lead into what I'm about to discuss and what you'll be seeing here. And then I'll throw in some harmonic content later to show off what harmonics will look like as well and to kind of mix things up a little bit so it's not perfect. So to first start off with at the top, we'll go through the controls of power quality. Up here at the top, exits back out to the main menu I was just in. Static view lets the screen freeze in time. So if you're seeing something, you want to capture it or move cables around or do what you need to do, but keep what's on the screen, it'll freeze in time when you hit that button. If I want to go back to reading in real time, I can hit the live view button now that it's appeared and go back to reading in real time. Load data. When you go to save data, which you'll see in a little bit as well, you can then reload data that you've saved in the past to review it in your power quality screen if you want to bring it up as if you were on the site again. Save saves the results and lets you choose what you want to save inside power quality. Print lets you print out a image or a PDF of what you're seeing in here as well. And then options lets you choose a couple bit of customization for power quality, mainly in the vector diagram section. For the vector diagram here in front in the wiring check section, you can choose whether you want to see your vectors in a clockwise or counterclockwise rotation, whether you want the 0 point to be either a 12 o'clock or the 3 o'clock position, and whether you're dealing with leading or lagging current values and how you want it to rotate around in your vector diagram. As well, for customization of the wiring check, we offer the ability to set a minimum load on the wiring check, so anything right now below 1/4 of an amp will not show up as a current vector on your diagram. And then the clamp-on multiplier, that is if you're using a rope probe, clamp probe, any kind of primary probe to then measure current. And if that has a multiplier built into it, whether it's 10 to 1, something like that, you can put in that multiplier here if applicable. So starting with the wiring check, This gives you the ability to look at the vector diagram at the site you're at. So with, like I was saying earlier, with the site I have, perfect 0, 120, 240 Y service I'm generating into this. So I see my A, B, and C phase voltages and currents all lined up perfectly across, as you would expect in a perfect, true three-phase Y system. With that, right below all of the controls I was talking about, you get the ability to choose between what section of power quality you want to look at and what you want to be. Wiring check is this screen here, and it gives you the ability to choose service wires. Service wires being how many wires are at that site, or how many are applicable to the site or service that you are hooked up to. For example, with this being a Y service I'm generating here, I could select 4 wire. And now the service, you'll see, has changed to a YABC service. It detects that automatically by the vectors being seen on all 3 phases, and determines, because I'm seeing delivered power on A, B, and C, and I've selected 4 wire, it knows it's a Y service. And we'll tell you it's a Y service. There's no problems with the service. Life's good. If I chose 3 wire, I'm going there. It assumes it's a delta service at that point. Brings up a delta ABC, says there's no problems because I've got a 3-phase, 3-wire delta, and I'm hooked up to, and this is the diagram that I would be seeing. Phase A, B, and C, this will either show delivered, received, or no load. So depending on how you have your connections hooked up, you can use this as a way to, 1, troubleshoot your own wiring. So if you're saying received on 1 phase and delivered on 2, you might have something backwards in your hookup. But this is also good for troubleshooting the site as well, to see, make sure everything's wired correctly and you're seeing what you want to see at that site, or what you would expect. And then the wiring check will also tell you if there's any problems, such as if I have to select 2 wire in this setup, it thinks something's odd because it's seeing 3 phases in the 2-wire setup, and it doesn't know what kind of wiring is at the site based on what you've told it. The 2.5 wire is usually used in more of like a 5S setup, where you have 3 voltages and 2 currents. So you can select the 2.5 wire in setups more like that. Moving on from wiring check, you have the secondary tab. This is raw metrics in a tabular format of what the RW is saying. Volts, amps, line-to-line voltage, total harmonic distortion at the site, raw values for watts, VARs, and VA, all listed out here in a tabular format for you. So you can see listed out every phase what it's saying. One thing I want to go back to real quick, you can also see these metrics down at the bottom of the screen in wiring check to then also match up with what you're seeing there. So if you notice, when I went into secondary, I saw my volts, I saw my amps, I saw my phase angles that I saw. But down here at the bottom of your screen as well, you will also see the same volts, same amps, and same phase angle for both voltage and current that you can then compare with the diagram here. So you can either see the metrics down at the bottom of your RW screen, or by going to the secondary tab and viewing them there. The next tab over is primary. This primary tab gives you a rough estimate as to what you would be seeing on the primary based on perfect conditions. With that being said, over here at the right, you'll see a PT ratio and a CT ratio input for these. So for example, I'm using 100 to 5 CTs over here. So if I typed in my CT ratio over here, 100 to 5, based on an estimate from what it's reading on the secondary right now, it will give you an estimate in a perfect world what that primary would be reading. You can also change the PT ratio as well. So if I had some form of step down transformer for this setup, it was, let's say it was like 480 to 120, something like that. Based on the voltage I'm seeing, 120 volts right now on the secondary, it would estimate about 480 on the primary inside of this tab. Same with current. I've got 20 to, or not 21, but 100 to 5 CTs over here, 20 amps going into primary, 1 amp going into my secondary. So based on the secondary 1 amp reading, it's estimating the 20 amps in a perfect world. Trend data. You can use the RW to capture changes in volts, amps, watts, frequency, everything you see over here at the right. You can have the RW monitor and graph over time. The trend graph starts right when you go into power quality. So with this, it has started measuring volts ever since I entered power quality to show this off. And as of right now, it's continuing that graph on until I either exit power quality or save what I'm seeing. So with this, I can put a couple of these up so I can have volts up here. I can also show amps that I'm generating and any kind of fluctuation there. It is a graph of amplitude over time. So I can choose whatever I want to show here, volts. I can show the watt value as well, and if that's changing. Because this is a fairly stable load, there's not much change to it that I'm using, but in the field you would definitely see some form of fluctuations or changes depending on what the customer is using and what they decide to turn off and on while you're there at the site. Usually you don't have much control over that. And then the Waveform tab. Go over to the Waveform tab here. This Waveform tab will show you the waveform at the site that the RW is reading. And like I was saying earlier, for now, perfect sine waves that I'm generating into this. I'll throw in a little bit more harmonic content in the mix here in a little bit. But for what you're seeing at the site, if you want to look at the waveform and get a clearer picture of what the meter or device under test at the site is actually seeing, you can use this Waveform tab to get a visual voltage and current-wise as to what is being seen by that meter. And then not as pretty as when I put harmonic content into it, but the harmonics tab. This will show you the harmonic order, magnitude, and phase in RMS for each specific harmonic order. It'll show you the magnitude and phase for each harmonic order, in all the way up to the 60th order. So because this is a perfect sine wave, there's not much harmonic content on any of these phases, and you mostly see 120 volts on your first harmonic order with a little bit of noise on all the rest. I'll show you that a bit more in detail once I throw some harmonic content. So overall, this is an overview of power quality. You can look through each tab as much as you want. But once you're happy with what you're seeing, or you want to save what's being displayed or read by the RW, you have the ability to hit the save button here at the top. When you hit that save button, you get a couple options. The first one is if you want to save it to a specific site. If you want a little bit more information on sites and how all that plays together in the RW, I recommend looking at one of our other webinars that we did on sites. Or we can answer any kind of specific questions you have on sites as well. But you can associate power quality data to your site and run a report on it that way. And then you also get to choose what you want to save and what you want to export if you decide to export data. You get to be able to choose the wiring check data. If you want to save the waveform, back up. If you want to save the vector diagram that's being shown in wiring check, save that off. Secondary and primary data will be saved no matter what. It needs some form of metrics to save to a file. So secondary and primary data are saved by default. You have the option to save the trend data to a file, which you can then plot in Excel or another graphing software later on. You can save harmonic and waveform data. So if you see an odd waveform and you want to save that harmonic content or analyze it later on, save that data, as well as saving a waveform image. If you want a JPEG of the waveform screen so you can show somebody a picture of what you saw instead of just the raw data and the harmonic content, magnitude, phase, and all that, you can use the image instead to show that same data. So now we're going to go over a little bit more of the advanced parts of power quality, some things that might trip you up, as well as what you can do with harmonic content once you see it on power quality. So with that, one of the things that I've noticed out in the field, and one thing I've even done myself, is using a rope probe or a clamp probe, some form of primary probe, to measure current in the field in power quality. You can do that. So now I've grabbed a little clamp probe I have here in the office. You can plug a probe into the RW and instead read from the probe while in power quality. You can plug it into any phase and it will read current for that phase. So I'm going to plug it into A phase here in a second, go over to my primary, and we should be seeing 20 amps on IA down there at the bottom for metrics. I'm going to go plug that in right now. So I just plugged in the probe to the RW, and if you look down in IA, you'll see that no current is being read whatsoever because this is being held in my hand and it's not measuring any current. When you have a probe plugged in to the RW in power quality, the probe maintains priority. It will completely ignore what you have on the duct bill or what you're reading on the secondary side at the site once you plug in the probe. The probe takes priority over the duct bill. So now that I've got the clamp plugged in, if I go over to my primary and hook this up here, we should start seeing 20 amps down at the bottom under IA. Now I got my probe on there, and we now see the 20 amps on my primary under IA. With this tactic, you could use 3 different probes to then measure all 3 primary currents at a site at once and get a power quality reading of all of the primary values instead of just the secondary values. So that is an option. If you have multiple probes, you can plug it in or move the probe around as necessary. So you'll see if I move this probe to B, it's going to do the same thing as A as well. So I'm going to go move the probe real quick and I'll show you what I mean. So I'm unplugging the probe from A. And we should get our 1 amp back because now the probe has been removed from the circuit. It's now reading the duct bill instead because I don't have the probe plugged in. Now we're going to plug it into B. Now I'm holding the probe in my hand again. It's not reading current. The probe now takes priority over the duct bill insert. So we're reading 0 as I'm holding it here. And now we're going to go put it on the primary again. And now I've got my 20 amps back on B. So you can use a rope probe or a clamp probe or anything like that with the RW in power quality and use a probe for your current measurements as well inside of power quality. The other thing I want to go over is looking at harmonic content as well inside of power quality. Like I was saying, it is very highly unlikely that you will have a perfect sine wave at the site that you'll be looking at. So I want to show off a little bit of what harmonic content would look like inside of the power quality window on the RW, and then what you can do with that and the power of the RW under harmonic conditions. So let me go set up some harmonic content on the site right here behind me. I'll show you what harmonic content looks like on the RW. Now I've removed power from my site, so the RW is not reading anything, and now I'm going to change from a perfect sine wave to some really bad harmonic content. So the RW can take a look at that. All right, perfect. So now the RW should be reading some harmonic content. Notice, though, that my wiring check did not change because I did not change any of the phase angles. But you'll see once I get to the waveform and some of the metrics, you'll start seeing the effect that this harmonic content is going to have on the rest of the system. Now if I go back to my 4-wire, still everything's telling me it looks good, but then I can start really digging into it when I look at the secondary side. If you notice, I still have 120 volts, like I thought, on all 3 phases, and I still have my amp on the secondary. Yeah, I'm still generating the 20 amps. However, the one biggest thing you might see is the total harmonic distortion for voltage and current. Voltage went up to 7% THD, or total harmonic distortion. But current is way out there, 40% total harmonic distortion. Now I'm looking at that and I'm thinking, all right, what in the world is my meter seeing at the site? I look at my waveform. That doesn't look that great. I don't like that at the site. So what I can do, if I'm concerned about this harmonic content that I'm seeing at my site, I can save that data and do several things with it. One of them being saving it for later, so I can look at it, take it back to the shop, analyze it, see what might be going on. But the biggest strength that this RW has is to then save this content and regenerate it later. Whether taking the file being generated from the RW and generating it again on the RW, whether it's in the shop or out in the field as a phantom load, or taking the same files that the RW generates, bringing that over to our WattNet suite, and then regenerating that on one of our test boards. So to do that, if I wanted to save all this, I can choose to save this specific data. So if I want to save this harmonic content off, I want to create a file from it. I want to be able to create what we call the COE file, which is it's a coefficient file that we use to then tell the equipment what harmonic order, magnitude, and phase, just like what we were seeing in the harmonic tab, and use that to generate what we just saw at the site. So with this, if I want to export out this waveform to a file I can then use either in the RW or in our WattNet suite for the test board, we can then select you want harmonic and waveform data checked, as well as the waveform image. Both of these need to be checked. And then if you want that file, we want to hit export. So then with that being said, I've got everything checked there. I had wiring check, primary, secondary, and then all the waveform stuff. It's going to step through each one of those and tell you where you want to export it out. So with this, I'm just going to keep it named as the default. For this one, this is the primary data. Go ahead and save that off here. Generated that CSV file. This is the secondary tab. I want to save that data. So I can hit save and save that CSV file off. Once it gets to the harmonic section, it's going to ask if it wants to be imported into WinBoard 3. This being our WattNet suite of software, WinBoard 3 is built into WattNet Basic, Express, Limited, and Plus. So if you're wanting to use this on the test board, you can hit yes. If you want to use it locally on the RW, you can hit no. And then it's also going to save your harmonic content and that table of harmonic order, magnitude, and phase as a CSV file. I can then hit save on that as well. And then this is the biggest one. These are the sine table values in COE files. These files are the ones that we want to then regenerate that harmonic content that I just saw right here. So I can name this whatever I want. For this default test, I'm going to leave it the same as well, but if you want to name it, 1, 2, 3, test away, or wherever your site is at, you can also name it with those so you can then know what harmonic content came from what site. And you'll see the little trick behind that here in a second once I go to view those files. So I do want to save these files. I want to go ahead and save what I just saw because I don't like this that I'm seeing at the site, and I want to look at it later. So now my sine wave files have been generated in this path. So I can go take a look at those. So now I've gotten files, I've got the COE files that I want to then regenerate those later. Let's go take a look at those files real quick. So I'll exit out of power quality. Let's go take a look at the RW of what I just captured. So I'll go browse on my RW under my W20 folder that I saved it under. And you'll notice I now have these defaults as of May 21st, which is today, these COE files that were generated. And you'll notice in the name, there's IA, IB, and IC, VA, VB, and VC. These are all 3 voltages and all 3 currents that were just read by the RW in a file format that the RW can then use to regenerate. If you want to get more in depth on actually using these files in the RW, I would recommend looking at one of our ANSI and non-sinusoidal waveform testing webinars that I did on the RW. You can load these files into meter testing and use these COE files to generate that same harmonic content using the RW. And the RW also has the ability to do non-sinusoidal waveform testing using this format as well. And you can build your own. But for the power quality section, you can use what you capture on the RW and then either take these files and load them into the RW and test that way, or take these files as well and move them over to our WattNet suite to then test on your 4,000 test boards in the shop as well. Got to get back to my presentation here. With all that being said, I want to open up the floor for any kind of questions or anything I can answer on power quality. For this section, you have the chat feature in WebEx. I recommend using the chat feature to type your question out. If you type your question out, I will read your question and get to it. If you would prefer to talk about your question, please let us know. Say you have a question. We will unmute you from WebEx, and we can talk about your question. With that being said, if you have any questions, please post them in chat. I'll get to them, or let me know you have a question. First question I saw from Virgil: how often is the RMS value calculated with this recorder? The RW updates the RMS value on the physical UI roughly every second. It'll update. The internal standard processes it a bit quicker than that, but in terms of UI and updating, it updates about every second or so in real time what you're seeing at the site. But the internal standard does it a bit faster than that, but we can only update the screen so quickly. Question here: are phasers in the RW based on 60 Hertz component of a waveform or an RMS value? Think about that one real quick. I'm sorry. Let me try to answer that question, and if I don't answer it directly, let me know, and I can either one, get you more information, or two, rephrase my answer. For what I'm assuming is the vectors in this case for the RW, those are based on a RMS reading that you're getting from the site. This can be used at either 50 Hertz or 60 Hertz applications. Anywhere usually from 48 to 62 Hertz is this functional at. So it measures anything between there to then help generate those vectors in the vector diagram. Waveform data stored, is there a particular moment of data that's stored, or is that some trend in harmonic? What is saved is at the moment of save. So either what you've frozen in using the static view, or when you hit save, what is actually being read at that moment in time is what's saved in terms of vector diagram, harmonic content, and all of that. In terms of trend data, same thing. when you're using static view or live view, it's going to save in the file when you first go into power quality all the way up to either you stop it with the static view or when you go ahead and save that data. On the example you showed where the harmonic table values for fundamental values. So the harmonic content I was generating was a 60 hertz waveform. It would just had the harmonic content built into it. So the orders based on that are off of that reading from the RW. The RW is measuring frequency at that time and then using that frequency measurement to then determine the harmonic order as well. The RW does do some auto ranging in that to help determine that harmonic order based on the input frequency that it's detecting on its voltage and current setting. Any other questions on power quality or anything I can clarify? That is correct. The harmonics are updated every second as well. So if I go back to the harmonics tab, I still have it generating over here, so I'll show you that real quick as well. So going back into power quality here under the harmonics tab, I'm still generating that harmonic content we saw earlier under my waveforms. You can still see that there. If I show all three phases here, you'll see I'm generating roughly the same thing on every phase. So with the harmonics, these are continuously updating as fast as the UI can handle it. So the internal RX standard to that RW is now reading and updating the metrics as quickly as possible as it's reading. What are acceptable values for total harmonic distortion for voltage and current? That's kind of up to you, your utility, or your company. In that case, what is an acceptable harmonic distortion? The RW doesn't really tell you exactly a hard yes or a hard no for what is acceptable in terms of THD. That's really going to be up to you or your utility company, anything like that, to determine is this an acceptable amount of distortion to the site? Is this waveform acceptable? What do we need to do to fix this, if anything? And use the auditing tools at your disposal with the RW to help make that call. What is the sampling rate of the waveform? We have a specific sampling rate for the internal RX standard. I don't know that off the top of my head right now. If you're wanting to get that sampling rate from us, I will have our email at the end of this. Please shoot us an email if you have any questions on that. I can find that exact sampling rate number for you and get that to you. All these questions are good. I appreciate the questions. What is the highest harmonic recorder? The RW goes up to the 60th order of harmonic. Any other questions? I'll give about 15 to 30 more seconds. All right. So for the last part of the presentation, I want to also talk about our We Meet event. We are still having We Meet this year. We have moved it to middle September, September 15th, 16th, and 17th here in Lafayette, Indiana. This is for you that might not know, this is a user event where other utilities, manufacturers, anybody that wants to sign up can come, get hands-on with some of our software, and it's a 3-day course learning about some hardware and software advances that Radian are doing. Getting some hands-on training with some of our newest pieces of equipment, and talking with myself and all of our other staff here at Radian, engaging with us and sharing knowledge between all of us all in one 3-day forum and classroom session. If you're interested in this, you can go to our website at radianresearch.com and register today for We Meet coming up this mid-September. And with that, I want to thank everybody for joining my webinar today. If you have any questions, you can also visit radianresearch.com. We have several videos and other webinars posted on our website for your viewing pleasure. And as well, if you have any questions on anything, whether it is the RW, power quality, or something else in general, please feel free to email myself and the rest of our technical support staff at technicalsupport@radianresearch.com. As always, we enjoy being your solutions partner and look forward to working with you on any questions and any solutions that you may be looking for on our end. As well, you can also reach us, myself as well, at 765-449-5576. I appreciate you all joining the webinar today. I hope you all stay safe and have a great Memorial Day weekend. Thank you. I'll see you at the next webinar.